Let's see here. Let's do the absolute value one. See what happens if A. Here's the absolute value function. See, let's make everything equal to 1 right now. There. Well, no, I want D to be 0. And I want C to be 0. So there's our absolute value function. So what do you think if A becomes an integer greater than 1, what do you think is going to happen to the graph? The bigger A gets, the skinnier it becomes. What about if it becomes negative and it gets big? If you notice what happens between 0 and 1, it gets wider and wider and wider and wider. So if the coefficient in front is a fraction, the whole thing shrinks. If it's an integer greater than 1, then it gets skinnier. It's a vertical stretch. Okay, what do you think happens if this constant over here, what happens if D becomes bigger? The whole graph shifts up. If D becomes negative, it goes down. Why doesn't it flip directions with D? Why doesn't it flip directions? If D is negative, why doesn't that flip directions of the graph? Yeah, D is a constant. It has nothing to do with X. It just takes whatever values your function has and adds or subtracts that value, so it either goes up or down. That's all it does. Now C, inside here, if C becomes positive, what happens to the graph? It shifts to, because it's inside, it shifts the opposite, it shifts to the left. If I go to the right, it goes to the left. If I go to the left, it goes to the right. That's all C does. Now, how about B, the coefficient of X? If B is positive, if it gets bigger, what happens to the graph? No. Remember, inside is horizontal. What's happening is horizontally, it's constricting. A horizontal constriction looks like a vertical stretch. Remember, it's always opposites. So if it's a vertical stretch, it looks the same as a horizontal constriction. If it's a horizontal stretch, what's it going to look like in vertical? Compression. So if my B becomes between 0 and 1, it looks like a vertical compression. What it really is, it's a vertical, it's a horizontal stretch.
So they're not the same. They just look the same.
They're opposites of each other. Yeah, they're not the same. You would think that this is a vertical compression. No, because all I did was change B. B is the coefficient of x inside the function. Since B is a fraction, I've stretched it out. Remember, it's opposite of what the vertical is. Again, these things, it sounds easy in the concept, but it takes practice to understand. Whatever happens outside, it is what it is. What happens inside is always opposite of what it is. So let's look at if B is 1/3, if A is -1. So we're looking at number 3. If A is -1, B is 1/3, what is C? 0, because there's no horizontal shift. What's D? 0. So let's go back to our graph. D is 0, C is 0, B is 1/3, so it's 0.3. And A is -1. So what that means, we know it has to point down, but because the coefficient of x is a fraction, that means it's a horizontal stretch. That means it has to be close, very close to the x-axis. Which number is that? A. So that one is A. Because it happens inside and it's a fraction. Let me write these steps down. Actually, you have them all. You have them all here. You have them all there, what happens. And the other sheet I gave you all. So we have our function A, f of bx plus c plus d. What happens with A? There are only two things. Well, if A is between 0 and 1, what happens? Why is it a vertical shrink? It's outside, so it's vertical. And because whatever happens, since it's getting small, yeah, so this is a vertical. It all depends on who you ask. It's a vertical stomp. This is Texas, so we're stomping on it. If A is between 0 and 1, you're vertically stomping on it. It's going to get very close to the end. If A is greater than 1, it's vertical. See, I don't like the word stretch. It's more like a vertical pull. You're pulling it up or pulling it down. So yeah, that's really good. Either you stomp on it, it gets flat, or you pull it and it gets skinny. That's what happens with A. Now inside there, what happens with B? If B is between 0 and 1, it happens inside there, so it's horizontal. Is it a, let's go back. Is it a stretch? Let's see. Let's go back to put everything in ones. So if B is between 0 and 1, what's happening to it?
Horizontal strip.
It's a horizontal stretch. Or pull. It's a horizontal pull. You're pulling it apart. Remember, it's the opposite. Since if it's a fraction, it's a vertical shrink. It's just the opposite. It's a horizontal stretch. Now, what if B is greater than 1? It's going to be a horizontal what? Remember, vertically, it's a stretch. This one's going to be a push. You're going to squash it. You're going to shrink it. So when B is greater than 1, it goes horizontally, you're pushing it. That's why I have a push. It's done horizontally. Because it's just the opposite of what's happening vertically. What about C? What does C actually do for us?
That considered the center of the constant? Because it doesn't really affect X, does it?
It does, because it's inside the function. Because remember, X is your independent variable. It could be anything you wanted to. So if we had X plus 2 squared, I can't square it until you define X, I add 2 to it, and then I square it. So it's changing the value you put in there into the function.
I just asked the question because I know, like, it moves the whole graph just like B does, so. It should. That's not really the same.
Yeah, it's a horizontal, yeah, C is a shift. So basically, let's see if it matters. So it doesn't matter whether it's between 0 and 1 or outside 0 and 1, it's just a horizontal shift. Opposite direction. So it doesn't matter. Why? Because C doesn't directly affect X like B does. So this is a horizontal shift of the graph. Opposite direction. If C is positive, it moves to the left. If C is negative, it moves to the right. So opposite direction. D doesn't matter if it's fraction or integer, what happens with it? It's a vertical shift. Why is it a vertical shift? Up or down? This one is left or right. Why is it a vertical shift?
This is essentially the same as the y-axis, like in a linear equation.
No, because it's outside. Because once you find the value of f of x, whatever you get there, then you add or subtract d to it. It just literally add it or subtract it. It makes it go up and down. Since it doesn't have anything directly to do with the function. Like c doesn't have anything directly to do with x. It's after you get x, then you add c to it. Here, after you get the value of y, then you add d to it.
Right, but like in a linear function, y equals mx plus b,
Mhm.
is b essentially the same thing as b in this?
Yes,
Yeah.
because if this function equals 0, then it's just this intercept. So yeah, it's yes and no, because if our function was 3x plus 2, that's f of x. So what if my polynomial was 2 times 3x plus 2 minus 5. Is it this graph just going down 5 units? No, because we have to do all this stuff. So we get 6x minus 1. So it's now it's going to be, so yeah, you would think it'd be the same thing, but no, it still has to do with the horizontal shift. But if the function is itself is a linear equation. So this is the easiest way to think about it. If it's outside, if it doesn't affect x directly, it's just a horizontal left and right shift. If it's outside the function, doesn't affect the y, it's just a vertical shift. What matters are your a and b. A, if it's a fraction, then it's a vertical shrink. A vertical shrink looks at the same thing as a horizontal stretch, and that's what they look like. That's exactly what they look like, because they're opposites. Again, if you have any cell phones out, I better not see any cell phones out. Let me put it this way. If I see any cell phones out, we're gonna have exams every day. Because if you know this stuff already, get out. You can take a test and ace out of this course. But if you're on your cell phones wasting my time, don't piss me off. How about this one? What's this one gonna do? Which direction is gonna go, up or down? It's gonna be positive, so it's up. What does this one do? What letter is this? A, B, C, or D? That's B. So if B is greater than 1, it's a horizontal shrink. Horizontal shrink. It pushes. So that means it gets skinnier going up. So here's the horizontal shrink or horizontal push. So that's got to be it. How about this one? It's a horizontal shift 2 spaces to the left because it's positive. So which one do we have going to the left? G. See, I hope my goal is to get you guys to a point where all you have to do now is get to a point, you look at the function, you can tell what the graph looks like or have a good idea of it. How about this one? It's a vertical shift, up or down. So it's a regular function going up 3 spaces. So which one? D. Because it goes straight up 3 spaces. So this is D. Okay, now we have a couple of things here. Horizontally, what happens? Shifts to the right 4 spaces. So automatically, which ones can we throw away? A, B, C, D, E. Yeah, except H.
That's the thing though, like, that was like, I could figure that graph out just from that premise only and not have to look at the rest of the equation. That's not really
And-
like.
Well, see, and that's the research I'm doing right now is just by having all these multiple choice, you really don't have to learn anything. You can just learn the basic, okay, there's no horizontal, vertical shift. So only look at the shifting 4 spaces. That's it. Does it really help you understand? Yeah, but it gives you an idea what's going on. So we know this one has to be H. Number 8. So we're looking at, is there a horizontal shift? No horizontal shift. Is there a vertical shift? So the graph goes down 3 spaces. So which one shifted down 3 spaces? So it's I. This one has no horizontal shift, goes down 2 spaces. And what does this negative do? Flips horizontally, vertically, I mean. So which one goes down 2 spaces and points down? F. And actually, we're only in the beginning part of the semester too, so we're building up on this stuff. Being able to look at a function, look at a graph, look at a function and understand what graph you're having. You now have a mindset of what the answer should be. It's the numbers that whatever you get, you know if it's right or wrong. So, all right, so let's look at the library functions. We only did one function so far. Let's look at the other ones. A constant function. What does a constant function look like? For example, this would be a constant, so it's a k. So let's say we had f of x equals 2. Yes.
Function without asymptotes.
No. Okay, you can't really just say a straight line. Because how many straight lines are there? There's horizontal, vertical, there's diagonal, there's positive, there's negative. You can't really say. So, but it has a special, unique one. Are there any x's in that equation?
So,
Since it has no x's, it cannot have an x-intercept. Since it cannot have an x-intercept, what's the only way the graph can look like?
horizontal. Like, if it doesn't.
Vertical goes up and down. By definition, it'll cross the x-axis. So, so in this case, this is a constant function. It is a straight line, yes, but it's a horizontal line. The slope is 0 in this case.
I was thinking
It can't have an x-intercept, so it's vertical. But no, I know what you're thinking. I knew what you were thinking. Okay, so what's my domain in this function?
It's negative infinity for infinity.
Negative, you can't just say infinity. Infinity is positive. So it's negative infinity to positive infinity. We can write it like this. But that's the same thing as all real numbers. It just makes it much easier to write all real numbers. What's my range? It's just 2. It's just whatever the constant is. Since it's that, since this is my function, in this case, it would be just 2. Because that's any x you give me, y is always going to be 2. That's a constant function. No, since there's no x, it cannot have an x-intercept. So that's why it has to be horizontal. Now we have another type called the linear function. Like this. What does that graph look like?
It's just a diagonal line from the origin.
Right. It's a diagonal line going from down here through the origin. Yes. Yes. So whatever x is, y is equal to the same thing. It's called an identity function. But this is the basic one for linear equations. Remember, it also has the ax plus c plus d, all this sort of stuff. So what's my domain here? All right, all real numbers. What's my range? Right, very good. And look at all the other stuff we're gonna talk about later on too. And a lot of this stuff you don't need to do any work. Just look at the function. A quadratic equation. What does a quadratic equation look like? The equation x squared. What does the graph look like?
Like a parabola?
Not like a parabola.
No,
What's that called?
Yeah.
It is a parabola, not like a parabola. It is a parabola. It is a parabola. Yeah, I love doing this because I love watching students like they're either Harry Potter, Wingardium Leviosa. So yeah, it's that. What's my domain?
Well,
Yep, because the lines keep on going forever and ever. So I can put negative x's in there, I can put positive x's, and I can put 0. So it's all real numbers.
Turbine confused me because I'm always associating that with a graph that has an asymptote, so that's why I was.
We'll get to some of those. But when it's a quadratic equation like this, it can have an asymptotes are simply where the function is undefined. That's an asymptote. But x squared, it goes on infinitely forever. What's my range? What's that?
Zero to positive infinity.
Yeah. 0 to positive infinity. Or y is greater than equal to 0. Either one of those works.
On one above it, would have to, why do you use the parentheses and brackets,
In this one,
the linear functions? Or wait, the constant, yes.
because remember,
Okay.
brackets mean you can use it, parentheses mean you can't use it. Then the other side, cubic function. This one, a cubic means cubed, 3. Because remember, I'm trying to get you to a point where you can look at a function and tell me as much as you can about it. So what does this graph look like? One more time. Yes. But in this one here, since there's no real shifting, it simply goes like this. It goes through the origin and it goes, it's an ever increasing function. And this is the most simplistic case of it. And you're right. The graph you had correctly in the air was that roller coaster one. I almost start thinking you Hermione. So what's my domain? All real numbers, because x can be anything, positive, negative, and 0. What's my range? All real numbers. Notice the difference in these two. Why can this one, they both have all real numbers for my input. Why is this one limited in the output and this one could be anything? What's that?
Quadratic equation goes to positive after y.
And why is that? Because
It's squared,
because it's squared. If you put a negative number inside and square it, what happens?
positive.
It becomes positive. If you put a negative number and cube it, so -2 times -2 times -2 becomes negative. So we can extend our logic by looking at the degrees. Remember, these are called degrees. The degree is the highest exponent of a function. If the degree is even, then your graph will have this basic shape. You can't really have negative answers. Well, you can once it starts shifting, but the basic shape of it, it'll never have negatives because you can't. If it's 2, 4, 6, 8, 10, if it's an even exponent, you can't. If you put a negative, it becomes positive. If it's an odd degree, then you can have positives and negatives. Let's go one step further. End behavior. End behavior is what happens at the end of the graph, at both ends. If it's an even degree, both ends always point the same direction. If it's even. Same direction. Remember, what's A? What does A represent? A represents the number in front of the function. This is your polynomial. A is your coefficient of your function. If A is positive, it points up. If A is negative, it points down. So if there's a negative in front of our x squared, we know the graph points down. Same thing here now. For an odd powered function, the end behavior is they have to point in opposite directions. Is this an increasing or decreasing function? Or both?
What is it?
Is this an increasing or decreasing function? Why?
Because from starting from left to right, it's going up.
Exactly. As you go always from left to right, the graph is always going up. So it's always increasing function. Because if A is positive, it's an increasing function. If A is negative, it switches. And they have to point opposite directions. All right. So let's look at square root radical. When we say radical, we mean that little symbol there. That's a radical.
Yeah.
The square root thingy, the root thingy, because this one is a cube root radical.
What is X? Is that the radicand?
Yeah.
Okay.
Those names I hate also. That's why I said the X inside. So why do they call this a square root? Why do they call this a cube root? Yes and no, but it's not really a degree. You can't really say this is not a third. This number here is called the root. That number there inside that V, that's the root. So the reason this is called a square root, because there's an invisible 2 right there. Why are they important? What do they represent? Radicals. So we have the square root of x versus the cube root of x. And we can extrapolate this to odd power roots and even power roots. What is this answer? Why is it 2? Yeah, because 4, if we break it down, is 2 times 2. This invisible 2 right here, the root, tells us how many of a kind do I need to take it out. I need 2 of a kind to remove it outside the radical. So since I have 2 2's, I can take them out of the radical and there's nothing left. So I don't need that anymore. The square root of 25. 25 breaks down to 5 times 5. There's 2 of a kind, so I could put it out in front. There's nothing left inside there, so I don't need that. So that's how come the square root of 25 is 5. What about the square root of 8? Nah. First thing you always do is prime factorize your number. What is 8 made up of? 4 times 2. What is 4 made up of? So 8 is made up of 2 times 2 times 2. This number here tells me I need 2 of a kind. Here's 2 of a kind. It comes out in front. So what's left inside there? There's the answer. That's how you simplify a radical. Cube root of 8. What is 8 made up of? 4 times 2. So it's cube root of 2 times 2 times 2. What does this tell me? I need 3 of a kind, and here they are. There's 3 of a kind. I put it out in front. There's nothing left inside there. It's gone.
I just struggle with that. It is like so like basic algebra, but it never was explained to me, and I just always try to mimic it every time I try to do it.
And that's so many students do that because the expression, and they said use a calculator, but that's all there is to it. The reason being is because what if we had the cube root of 16? I don't want decimal answers, so you can't use a calculator. Simplify that one. So 16 is made up of 4 times 4, which is 2 times 2. I need 3 of a kind, so they go out in front. So that's gone. So what I have left is that 2. So there's my simplified version.
I always do that, like that tree thing that you're doing right there.
Prime factorization.
And then I would get, but then from that point, I was just like, I think it's supposed to be like this.
Yeah. It's the let's try this. Let's put Is it one of the multiple choice answers? So that's what radicals are all about. Which is why can you do that? No, because you can't say the answer is -2 because, as you said earlier, -2 times -2 is what? +4. That doesn't work. So is it +2? +2, +2 is not -4. So you can't do that. But we can do it with odd roots because 8 is made up of -2 times -2 times -2. Or you could say -2 times 2 times 2, which means they're all negative. So if I take the cube root of that, I have 3 of a kind, has to be the same kind. So the answer is -2.
Never went into cube roots.
And then once you understand these two, we can go to any order you want to. As if we had 16th root of x, same logic. We just need 16 of a kind. Or if we had 19th root, because that's odd, the answer could be positive, negative, or 0. This one, the answers can only be positive or 0.
Very rarely did cube roots, if anything. We just did square roots, and then if it was a negative radicand, it was an imaginary.
And then that limits you to what you can do because you won't, it's not always square roots a lot of times. What if you're dealing with volumes of something, which is a third degree polynomial? So that's what radicals are about. Now we have to go to the graphs. Since we know we can't have negatives inside there, what's the graph going to look like? So our x's can either be positive or 0. They can't be negative. If x is 0, what do we get? 0. If x is 1, what's the square root of 1? If x is 4, and so on, so when x is 9, so the graph looks like this. because we are restricted. The domain is restricted to this function. I can only go x being greater than or equal to 0. Which means my range is the same thing. I'm stuck in the first quadrant. I can go from 0 to infinity, or y is greater than equal to 0. If you have questions, please holler. You don't get points for not asking questions.
What the Y value is?
The y value, just look at this thing. When I plugged it in there, if x is 0, y is 0. That's the smallest I can put in there because x can't be negative. Then I can keep on going. I can keep on going forever.
For 2, for example, if you put 2.
Then I get square root of 2.
I'm sorry.
If I put 4 in there, the square root of 4 is 2.
So the f of x is really just y equals.
Y, yeah. Yes. So f of x is the same thing as y. It just makes it more impressive, actually. That's all it does. So now, because the square roots can only be in the positive realm, we know that cube roots can be positive, negative, and 0. So it'll have the same similar structure in the positive realm and 0, but we can also include the negative. So far, so good. So the domain, all real numbers, and all real numbers, and domain and range of a cubic function.
Go back to the square.
So if you notice, the way I have this thing set up really is on this side, we have even powers or even roots. This side, all three of these are odd. A linear equation. What's the degree of the linear equation? 1. It's odd. The degree of a cubic function is 3. It can be positive, negative, or 0. The root can be positive. If it's odd, it can be positive, negative, 0. So if you have an odd root, odd power, or anything like that, we know the answer can be positive, negative, or 0. Now, does that change? Yes. A rational function. What does rational mean? We've talked about radicals down here, but what's a rational? Yes. It's a fraction. 1 over x.
Ratio.
Exactly. The first 5 letters is ratio. Since we have x on the bottom, that changes the rules. What can we not have in the bottom? 0. So that means our domain means what? What can we not use in the domain? Yes. Since x is on the bottom, x cannot equal 0. Since we cannot use 0, because what does it do to our function? Makes it undefined. We've just defined our vertical asymptote. It occurs at x equals 0. So a vertical asymptote are x values where the function is undefined. That's an asymptote. So now we have to look at 1 over x. Two things we have to look at. We know we can't have 0. When x is 1, What is it? What is y? When x goes to the right at 2, at 10, at 100, what happens to this number? What is when x is 2, what do we get? A half. When x is 10, yes. So from here, the farther we go out, it gets closer and closer and closer to the x-axis. How about as we get closer to 0, what happens there? When x is 1/2. So when you have 1 over 1/2, take the top and flip the bottom, we get 2.
It's closer to the y-axis.
Yeah, so whatever fraction you have, it becomes that denominator. So the closer we get to the x value, the closer we get to 0. Yes. Rational functions that have x on the bottom. Yes. So when x is positive, that's what it looks like. What happens when x is negative? Which quadrant? Yes. I was going to stop you from changing your mind. So it's going to be in the third quadrant. It's going to look like this. So what's our range? You can, or you can simply say that y cannot equal 0. X cannot equal 0 because you have an asymptote at 0. Y cannot equal 0 because the top can never equal 0. It's a horizontal asymptote. So asymptotes, now how do we know these are asymptotes? Because it's an asymptote, because as we get closer to that value, in other words, since x equals 0, as we get closer to x from the right-hand side, what happens to this number? Where does it go? To where?
Wherever.
To infinity. Not wherever. It has to be a number.
I said forever.
Oh, forever. Okay, yeah. As it gets closer to 0 from the left, what happens? It goes to negative infinity. So that's what defines an asymptote, a vertical asymptote. As we get closer to it, it goes to either positive or negative infinity. That's what defines an asymptote. A horizontal asymptote, as we get closer to it, it goes to the same thing. It goes to infinity, negative infinity. Rational squared function, which is 1 over x squared. What do we notice about this function? It's a fraction, so we know it has asymptotes. Where are the asymptotes at? X equals 0, because x cannot be 0. So what happens as we get closer from the right-hand side to 0? Where does it go? The same as this one. As we get closer to 0, it goes to infinity. So this graph looks like this. On that side, it just goes faster because it's squared. What about from the left-hand side? It'd be in quadrant 2 because it cannot equal 0. So it looks like the Atari symbol. Because it's squared, my range is y has to be greater than 0. My domain is x cannot equal 0. So far, so good. absolute value function. We just talked about that one. What does the graph look like? No. Was that? That's a U. A V, yes. That was the same graph you had for the there, it's a V. Because same reason. If you had to give this absolute value a formula, what would it be? Think of it this way. If you had to give the absolute value, so if I put -2 in there, I get 2. If I put 0 in there, I get 0. And if I put +2, I get 2. So what formula would you think would define this operation? Remember, we cannot have any negatives here. So what operation always gets rid of the negatives? If you square something. So if we squared something, got rid of the negatives, but when we square it, we make it bigger. How do we get it back down to normal size? What's that? Nope. Square root. Because if I had -2 and I square it, I get 4, and square root of 4 is 2, makes it a +2. So this is the formula that we can use to define the absolute value of x. So what's my domain? Yeah, all real numbers. Because remember, whenever you're answering domain and range questions, always ask 3 questions. Can it be negative? Can it be positive? Can it be 0? If it's yes, 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 all real numbers. How about the range? Can it be negative? No, because there's no graph down here. Can it be 0? Yes. Can it be positive? So y is greater than equal to 0 or 0 to infinity. So far, so good. We're gonna have another symbol similar to this one, but you don't see too often. Greatest integer function. Ever hear or ever see the greatest integer function? Here's what it looks like. What the greatest integer function? What is an integer? First off, it's like a whole number. It's like a whole number, but it can be positive, negative, or 0. It can't be fractions. So that's why they call it the greatest integer function. Here's the graph of it. What the greatest integer function, what it does is you only look at the integer. Whatever the decimal is, get rid of it. So when we have 0, what if we put 0 in there, what's the answer? 0. If I gave you 0.1, what would be the greatest integer? 0. If I gave you 0.9, 0. If I gave you 1.0, Remember, get rid of the decimal. So now it jumps up to 1. So it could be all these decimals, and then when I get to the integer, it jumps up. So all these decimals, when I get to the next one, it jumps up. Let's see if I exactly. That's what this is called a stair stepper function. And it also goes down forever in infinity.
What's the significance of closed and open circuit?
When I'm going over here at 1.0, it's not this graph anymore. It jumps up here.
Okay. Oh,
So,
okay.
so at the integers, it has to be that integer.
Okay.
Let me draw these graphs here. So it's 0 to open, 0 to open, 0 to open. So the greatest integer function just truncates the decimals. So what's my domain? Yep, all real numbers. Even though it's stair stepper, you think, oh, it can't be all. Yes, it is. So any number you have, just get rid of the decimal. What's my range?
All real numbers as well? No.
You can't have decimals.
Oh.
What can you only have? Why would whole numbers be a wrong answer? No, I know exactly what you were thinking. That's what went through my head first, but then I thought about, no, it can't be whole numbers. I'll show you why. In the whole scheme of things, when you were first in school, what numbers were you taught? You were taught 1, 2, 3, 4, 5, and all the way to infinity. What do you do with those? What do we call those? Counting numbers. Okay, that's pretty boring. Then we started expanding that with a 0 in front of it. Another name for that is natural numbers. Instead of counting, just natural numbers. Now, once we introduce a 0, it looks like a what? A whole. So these are defined as whole numbers. Whole numbers from 0 to infinity. And then we have integers, which go from negative infinity to positive infinity. And then we go from rational numbers, which are all the decimals. Yeah, so when you say whole numbers, it starts at 0, goes to infinity, even though you meant this. We have a couple more, but we're out of time. It's 12:40 already.
Oh.
Now time flies when you're listening to me. Okay, having fun. So we'll pick up from here next time, and we're gonna do some more. We have a couple more pictures to talk about.